Hello everyone, in this video I'm going to go through every single course that a math major takes, and we're going to go through them in the order in which you should take them. Now there are many other possible orderings, but I'm going to give you the most typical and perhaps what I think would be the most recommended order to take these courses in. If you are doing self-study, this is going to give you the exact order in which to study every single subject that an undergraduate math major takes. Also, at the end of the video, I will show you a couple other more strange and bizarre subjects. These are subjects that many people don't study. They'll have their math degree, but they won't study these subjects. And so we'll look at some of those more exotic subjects near the end of this video. I've also thrown in a few books that are not as widely known, and also a few classics which I'll show you near the end of the video. All right, let's go ahead and get started. Every math major has to start somewhere, and this is a good place to start if you have been away from mathematics for a while. This is Intermediate Algebra for college students, and this is the one by Angel. This is a great book that you can use for self-study or to supplement your current college level course. It even says for college students. This has pretty much everything you need to become super good at algebra. It's a modern book, so it's got great examples, great exercises. Yeah, it's super awesome. I will leave a link in the description, by the way, to all of these books in case you want to check them out. And it doesn't have to be this book, but this is a pretty good choice. After you've had some algebra, you can jump to what's called college algebra. This is typically offered at most colleges and universities in the US. This one is a book that you can use for such a course. It's called College Algebra Essentials, and it was written by Julie Miller. This course covers basic stuff like polynomials, logarithms, rational functions, the quadratic formula, systems of equations, and inequalities. You can see some of the topics here, but not super hard or anything, but it can be if you haven't had math in a long time. For me, when I took this course many, many years ago, I did struggle quite a bit, and I thought it was a challenging course. Many math majors do not like statistics, and I can relate. As a student, I also wasn't a huge fan. It wasn't until I started teaching statistics that I really started to appreciate how beautiful the subject actually is. This is a great way to learn statistics with a book like this. This one's called Understandable Statistics by Brass and Brass. I've actually taught statistics from this book many years ago. So great book. It's got really intuitive explanations. You can actually learn this at the same time that you're studying college algebra. So you could do both at the same time, but you probably want to have some intermediate algebra before jumping into stats, just so you have some math experience. There are some math things in statistics. It's really basic math, but having some algebra, I think, is a good stepping stone. After you take college algebra, there are two courses you can take. You can take pre-calculus or you can take trigonometry. Typically, those courses are taught using the same book. This is an example of such a book. This is the one by Beecher, Penna, and Benninger. This is like many other books. Most books on pre-calc and trig are excellent. This one is no exception. It's also a great book. These books are modern. They have really good examples. They have answers to the odd-numbered exercises usually, and they have great exercises. So you can use these to learn pre-calculus and trig. So you can take two courses with one book, which is really amazing. This is going to be a prerequisite for learning calculus at most universities here in the US. So after college algebra, again, it's pre-calc or trig. If you have to take them separately, I took them at the same time, but if you decide to take them separately, people always say, which should you take first? I think maybe pre-calc is a more natural transition because you do a lot of the things that you've already done in algebra. You do a lot of the same things. You do logarithms and exponentials again, although you do new things like matrices, hyperbolas, ellipses, and conic sections and stuff like that. So I would say pre-calc, then trig, but you can certainly take them at the same time. Once you have some algebra and you've taken pre-calc and trig, you're ready to tackle the calculus sequence. So calculus 1, calculus 2, and calculus 3. In the US, most calculus courses are taught using one book, and that book is used to teach Calc 1, Calc 2, Calc 3. This is a book that, I actually have used this to teach Calc 1, Calc 2, Calc 3. even some Calc 1 honors. And this is a great book. I have done a lot of the exercises from this book. It's awesome. There's other really good books out there. The one by Stewart is also really good. But I chose this one for this video because I think this one might be, I don't know, I don't want to say it's easier than the Stewart book, but it might be a little bit more gentle. And so if you're thinking about self-study, this could also be a really great choice. Why is there a physics book in this video? It's because physics is important, and I thought it would be a great opportunity to introduce it. So this is physics for students of science and engineering, and this one is by the famous Halliday and Resnick, right? So this is a classic book. I have a few editions of this book, and it's been used by tons of people over the years to learn physics. So you can take physics or learn physics on your own after you've had some calculus, okay? So my advice would be definitely take calculus before you learn physics. I somehow was able to take Calc 1 and Physics 1 at the same time, and it made my journey very, very challenging. So I don't recommend it. Make sure you take calculus before you take physics. Most schools don't even allow that anymore. So yeah, take calculus, then learn physics. As a math major, you usually take 2 physics courses. I took 3. It was mandatory for my degree at the time. So I took Physics 1, Physics 2, and Physics 3. And I liked all of them. It was very challenging and very eye-opening. Next up is differential equations. And notice there are 2 books here. I just wanted to talk about both of these very briefly because they're both excellent books. So differential equations is something you can take after you've had calculus. So once you've had calculus, you could actually just jump into differential equations. So this is the one by Shepley L. Ross, and this is a standard book. They both are fairly standard. This one is perhaps more standard. It has all the topics that you would expect to see in a regular differential equations course at the undergraduate level. I've taught differential equations. I've taught it many, many times. And so this content here, let me just say, is very standard. These are things that you'll see in pretty much every differential equations course across the U.S. in a college. So great book for self-study, great as a supplement. You can learn differential equations with this book. Now, some people think it's better to take linear algebra before you take differential equations, and I can see how there is value in that. In fact, when I've taught differential equations, I do teach some linear algebra in the class. That's in the book already. And that's the point. A lot of the linear algebra you need is already in the book. But if you wanted something with an extra emphasis on linear algebra, there's this book here. This is the one by Edwards and Penny. And I bought this book just for fun, and I thought it was very unique and interesting. Compared to my other differential equations books, I would say this one is extremely unique. It's probably the most unique one I have at this level. So if I compare this to all the other DE books I have, which I probably have like 8 of them, this one is super different. Okay, very, very different. So yeah, I recommend it. Also, I feel like it's a little bit harder. So you get some more interesting examples. And yeah, I like it quite a bit. Learning to write proofs is extremely important. And this is an appropriate time to begin learning that. So here we have 2 books. We have one on discrete mathematics. This is the one by Susanna Epp. This is probably the easiest discrete math book ever written. I think it's probably the best one for beginners. And then we have How to Read and Do Proofs by Daniel Solo. This is a proofwriting book. I've had this for quite some time. I haven't talked about it much for some reason, so I thought I should include some books in this video, which I haven't talked about too much. This is a book you can buy for self-study and use it to learn to write proofs. Highly recommend it. What happens is in colleges, there's usually a course you take. It's called something like Introduction to Proofwriting or Introduction to Higher Mathematics. It's some type of transition course, and typically it will use a book like this one here. At the same time, there's a course called Discrete Mathematics that's offered usually by computer science departments, and computer science students take it typically. However, if you're a math major and you have the opportunity to take discrete mathematics, I highly recommend you do. It is worth it. I was fortunate enough that I was a double major at the time. I was kind of like undecided. I was going to do computer science and math. So I got stuck taking both, and it was a blessing in disguise. Learning discrete math and learning how to write proofs at the same time made my proofs extra strong. It really, really did. Both classes kind of focused on different things, and I was able to just get a lot better at mathematics in one semester by learning both of these subjects. So I definitely recommend both of these. And again, this is not typically a course that math majors will take, but I highly recommend it. Discrete math, by the way, covers counting, probability, recurrence relations, sets, logic, proofs. You do a little bit of graph theory. So yeah, it's pretty cool. And this here is just a book on proof writing. So it's got different types of proofs from various areas of mathematics. But yeah, definitely worth learning both of these. Now that you know how to write proofs, a really good place to start with that is linear algebra. Now, this is a beginner book on linear algebra. This one is called Elementary Linear Algebra, and it's the one by Larson and Edwards. There's many other good linear algebra books. I just wanted to show you this one because this one is good for beginners. So it starts with systems of linear equations, matrices, determinants. So all the basic stuff that you would expect to learn in a linear algebra course. Now, the proofs are light, but they're still here. And so if you really want to learn everything, you should know how to write proofs. That's why I wanted to wait until proof writing was introduced. That way you get the most from your experience in linear algebra, right? Knowing how to write proofs is going to make your experience much better. This is a great book. It's got answers to some of the exercises, and great examples. So yeah, linear algebra. Here we have 3 different books for 3 different math subjects. And so we're going to go through each and talk about the prereqs for each subject. So first up, we have this one here. This is complex variables, and I chose this book because this is one that I haven't talked about too much. It's by Stephen D. Fisher. In order to learn complex variables, you should know how to write proofs, and you should know some calculus, which you already know, so you should be good to go. So if you've made it this far, in theory, you can jump into a book like this and learn complex variables. You'll find that when you're studying complex variables, it's kind of refreshing because a lot of the things that you've learned and a lot of the rules from calculus that you've learned still apply in the complex valued case. For example, the series tests are very similar. The rules for differentiation are very similar. The rules for limits are similar. There are some differences. And when you learn what those differences are, it's really kind of exciting. So yeah, great course. Shouldn't be too hard as long as your teacher is not like super, super hard. I had a friend who had a really hard teacher and it was really, really hard for him. I had a hard teacher, but my teacher was good. So I think that was the difference. This is a book that you can use to take courses in college known as mathematical statistics or statistical theory. I took 2 courses with this book. It's extremely challenging. What makes this hard is that, one, there's proofs. So if you don't know how to write proofs, it's going to be kind of challenging. The proofs aren't that hard. In hindsight, I should have been able to handle them. I mean, they were really easy proofs, but I was just learning. And so I had a really, really hard time. In fact, I had such a hard time that the first time I took this class, I withdrew after the first test. I was taking advanced calculus at the same time, and it was too much, which we haven't gotten to advanced calculus yet. So, but yeah, very challenging course. And it's one that I know math majors don't look forward to, but it's worth it. I think that it is quite an interesting subject. And then here we have partial differential equations. This is the book by Strauss. So basically, to learn this, you just need to know some calculus. And it helps to know how to write proofs. You know, the more math you know, the better, for sure. And I think the teacher is going to make a big difference in all of these courses, right? In all of these courses. I'm sorry, I just got to give it a whiff here. It's just calling me. Smells amazing. So PDEs, or partial differential equations, is a course that you could take after you know calculus and obviously after differential equations. One of the cool things about this course, by the way, is that a lot of the techniques that you learned in differential equations, you use them again in this course. Okay, let's keep going. 3 more math books, except this time the subjects are more challenging. Let's start with linear algebra. Again, that's right. This is the second time we're seeing linear algebra. This time, this is a proof-based course you would be taking in college. So typically, most colleges offer 2 courses on linear algebra, an intro course and a harder course. So this is a famous book that was used many years ago for that harder course at many good schools. It's called Linear Algebra. It's by Hoffman and Kunz. And this is my copy of that book. And it's a classic. Now, there are more modern books you can get. I usually recommend the book by Friedberg, but I thought for this video, let me just show you one of the classics from my collection. You could certainly still use this book to learn, and I could smell it from where I am, and I'm pretty far away actually, and I can actually smell the book. Wow, wow, it just releases this intoxicating odor. Hopefully your copy is as nice as mine. Next up is Abstract Algebra, and I chose this book because it's a wonderful book. It's great for beginners. This is contemporary abstract algebra. So in abstract algebra, you're going to study different algebraic structures. You're going to look at groups, rings, and fields, maybe modules, but probably not as an undergraduate. Mostly group theory and maybe a little bit of ring theory. Some schools offer 2 courses on abstract algebra as an undergrad. Oh, look, there's Paul Erdos. Sorry, Paul Erdos is a socially helpless Hungarian who has thought about more mathematical problems than anyone else in history. Oh, he is not socially helpless, or maybe he was. Yeah, Paul Erdos was a very, very unique person. Anyways, abstract algebra is a great subject. It was probably my favorite subject and probably still is. I think it's beautiful. There's a lot of really cool stuff you can learn in abstract algebra, and this is a really good book. So yeah. Advanced Calculus, also known as Real Analysis. So this is typically considered to be like the hardest course for math majors. People really struggle with this. You start with like sequences and then it goes from there. Basically, it's all the calculus stuff that you've already seen, except you prove it again. So you might say, you've already seen it, why is it so hard? It's just dealing with the inequalities and getting used to these types of proofs takes some work, right? Takes some work. This is an extremely challenging course for people. So this book, by the way, is pretty good. It's called Advanced Calculus, and it's the one by Fitzpatrick. So, and you can take 2 courses typically. I took 2 courses with this book as an undergrad. I got A's in both, but it was very, very challenging. It's no joke. Topology is considered by many people to be an extremely challenging subject, and it is. And I wanted to leave it for now in the video because you do need to see a lot of mathematics before jumping into topology. In particular, your proof writing needs to be really, really solid. You should be able to prove all of the basic things surrounding sets quickly and correctly, or on the spot, just to verify that they're true. You should be very, very comfortable manipulating sets and set theoretic proofs. And that will help you tremendously when you jump into something like topology. I mean, the more math you have, the more proof writing you have will help you. I took topology my last semester, and I thought it was great. However, many of my classmates did not think it was great. And the big difference between me and my classmates was that many of them were not seniors, they were juniors. And they were taking topology at the same time as advanced calculus, I think, in some cases. So very challenging to do that. Definitely take analysis first if you can, and leave topology to the end so you can get the most out of it. Okay, that's my advice. This book, by the way, is pretty good. It's a legendary book. It's the one by Monk Rees. The only thing I don't like about this book is that it doesn't have answers, but otherwise it's like the perfect topology book. Here we have 4 more books for 3 more subjects. So these subjects can kind of fit in different places throughout the sequence. So for example, number theory here, you would want to learn how to write proofs before taking number theory. So here we have the book by Rosen, and here we have the book by Long. Both of them are great. Number theory is typically not a required course for a math degree, so I kind of wanted to leave this to the end, but it's still great if you can take it, if you don't take it, I don't think it's the end of the world. I think other courses like advanced calculus are much more important to take as a math major. If you're only going to take a certain number of courses, definitely take analysis over number theory. But great course. You just have to know how to write proofs. And then differential geometry, definitely you have to know how to write proofs. And I would say take a course on advanced calculus before jumping into differential geometry. If your school even offers it, many colleges don't even offer differential geometry, or maybe they offer it as a grad level course sometimes. So Again, not something that's required typically for a math degree, but I wanted to include it, and also just to show you this book because it's so pretty and good looking. It's the one by Oslander. Combinatorial theory, so this would be a course called combinatorics at your local college. I took a course that was a combined course. It was called combinatorics and graph theory, and I used a discrete math book, kind of like the one by Epp, to take that course. So I saw both some combinatorics and some graph theory. This is an old school book. This is the one by Hall, and it's just on combinatorial theory, which is the theory of counting. And you can see how the book starts. Let me just show you really quick. It starts really basic. It talks about permutations at the very beginning there. A permutation is an ordered selection of objects from a set S. Yeah. So it starts off pretty basic and accelerates quite rapidly in this classic book. So other subjects that you can kind of take that we kind of missed throughout the sequence. So that is the best course sequence for math majors. Hopefully, after watching this video, you kind of know what to expect if you decide to study mathematics, or if you're already studying mathematics, you have some ideas for other books that you can use to supplement your learning. Or maybe you're just thinking about doing self-study, and now you actually know what the courses are that math majors actually take. I will leave links in the description of this video to all of these books. Also, if you want to learn math, I have courses on Udemy, but use my links, please, from my website, mathsorcerer.com. And if you found any value in this content, feel free to hit subscribe. Until next time, keep doing math.